Business Breakdowns is sponsored by Tegas. We created Business Breakdowns to uncover the lessons and frameworks behind every business, and that's what makes Tegas our perfect launch partner. Much of the foundational prep for these episodes gets started with research powered by Tegas. With Tegas, you can learn about any public or private company directly from former execs, customers, and industry experts, all of whom are in a position to offer unique insights into a company's growth, its customer value, and its competition. What makes Tegas different is that you don't have to lead your own expert calls. It offers instant access to the world's largest collection of investor-led call transcripts on companies like Coinbase, Hinge Health, and Farfetch. All you have to do is log in and you'll get instant access. Still want to do your own expert calls? Tegas also allows you access to experts for $300 a call, not the $1,000 or more that others charge. I can personally say that some of the most thoughtful investors in the world use Tegas and talk about it often. If you're ready to go deeper on any company and you appreciate the value of primary research, head to tegas.co/breakdowns for a free trial. That's tegas.co/breakdowns.
This is Business Breakdowns. Business Breakdowns is a series of conversations with investors and operators diving deep into a single business. For each business, we explore its history, its business model, its competitive advantages, and what makes it tick. We believe every business has lessons and secrets that investors and operators can learn from, and we are here to bring them to you. To find more episodes of Breakdowns, check out joincolossus.com. All opinions expressed by hosts and podcast guests are solely their own opinions. Hosts and podcast guests may maintain positions in the securities discussed in this podcast. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions.
Today, we're breaking down Solana. Founded in 2017 by an ex-wireless engineer from Qualcomm, Solana is a layer 1 blockchain like Bitcoin and Ethereum that has been built to process transactions as quickly and cheaply as possible. Where Bitcoin can process about 10 transactions per second and Ethereum around 30, Solana can handle over 60,000 transactions per second, and it can do so at a fraction of the cost. Unsurprisingly, Solana's network has attracted huge interest from developers, users, and investors alike over the last year. In this breakdown, we cover the killer app for decentralized ledgers, the history of on-chain transaction speeds, and the fundamental difference between software and blockchain technology. We then delve into the architecture that has enabled Solana's speed unlock and look at the platform's potential to become a huge piece of the world's financial infrastructure. To help me break down Solana, I'm joined by Kyle Samani, co-founder and managing partner at Multicoin Capital. So Kyle, while this is going to be a breakdown on Solana specifically, on which I think you're one of the great experts and someone who can explain it in ways that I think everyone listening will understand, I think it's probably necessary to take a step back from Solana and first frame how you view the opportunity or the landscape in blockchain technology, generally speaking. And maybe the first question I'll ask is, what do you think the killer app of decentralized ledgers or blockchains is, given that so many people think it's Bitcoin, it's this kind of new non-sovereign money? I think you have a different take. So maybe just frame the entire conversation by what the huge opportunity is here, and then we'll get more specifically into Solana.
The history of the crypto ecosystem, like all things, is kind of path dependent, and there's different cultural movements kind of that have bubbled up to the top of it at different points in time. Bitcoin was founded in 2009. Satoshi, I don't think, had a strong view of what Bitcoin should be or what it could do, but he made something that was a breakthrough in a number of ways. Ethereum took a lot of those same ideas and just said, hey, just make it a little bit more programmable. But there was no real plan for how to make it large scale. And certainly, again, even if you go look at Vitalik's first introduction of Ethereum, which was in January 2014 at the Miami keynote, it's about a 17-minute video. And you can tell he has no idea what this thing is useful for. He vaguely alludes to like a couple of DeFi concepts in the video, but can't coherently articulate what DeFi is or why it should matter. And the most important thing I would think we as an industry have learned really since the last 5 years or so is that the killer app for blockchains is DeFi. And I think you should probably interpret DeFi as broadly as possible. That means recreating existing financial contracts for trading spot assets, derivatives, options, interest rates, whatever. Certainly in this kind of new paradigm where you get auditability and composability and it's instant settlement, all those things are obvious. But I think the other implication of DeFi is then, can you take financial concepts and inject them into new places that haven't really traditionally had financial concepts in them? You're just now starting to see this in a little bit with NFTs and people starting to play with fractionalizing NFTs. You look at this loot game thing that just came out a few weeks ago, and you can see we're kind of at the tip of the iceberg of a lot of that stuff happening. I think if you add social tokens kind of onto that and then combine NFTs and social tokens, this is like a very ripe design space to do a lot of interesting new forms of capital formation, community engagement, creator monetization, all those things. But again, all of these are still kind of finance-centric concepts. And so kind of the conclusion I came to internally probably about a year ago was that what if you reframe the point of blockchains not as non-sovereign money that happens to be programmable, which is what Ethereum launched as, but what if you instead reframe blockchains as the best conceivable DeFi system that happens to have non-sovereign monetary properties to it? If you reframe the question that way, then the right design fundamentally probably is not something that looks like Bitcoin, but is something that is written from the ground up to really be finance native. And that probably means a few things. One, it means you need to have as low of latency as possible, because anything in finance that has derivatives means you have leverage. If you have leverage, you have risk of blowouts. And if you have risk of blowouts, you need to have low latency, you need to have high throughput so that you can manage liquidations and risk in the system. The other thing that probably means is you want to have super high performance programming languages and look at kind of where all HFT is written at the kind of bleeding edge of high performance real-time systems. And you want to be writing in those languages to just have optimized performance in every way. There's some other implications as well, but those are, like, broadly speaking, kind of the two obvious ones.
Maybe just one click deeper on the notion of DeFi as the North Star for crypto systems rather than non-sovereign money, right? Like very, very, very big change from, I think, what most people just starting to get familiar with this system would describe crypto as. They'd probably go straight to Bitcoin. But maybe this is the right time to compare sequentially actually what is happening here. Like, this is just a database and it's just a record of who owns what, whether it's Bitcoin or Solana or ETH or whatever. And there are really clever mechanisms for the world to all agree without any centralized authority on who owns what inside the ledger. And transactions per second maybe is one interesting data point to talk about from Bitcoin to ETH to something like Solana, given the frame that you just gave us. If all we're trying to do is change the state of that underlying database or ledger, and maybe just tell the transactions per second story, starting with Bitcoin all the way through where we are today and why you think that's interesting.
Bitcoin launched 2009. Satoshi, I believe it was 2010. Some people were like spamming the Bitcoin network or something. And in order to prevent the system getting overflooded with too many messages bouncing between the computers, Satoshi just like put in a very, very rudimentary fix, which is he just like added a few lines of code and said, blocks cannot be bigger than 1 megabyte. Super arbitrary determination. He definitely didn't consult with anyone publicly about it. My guess is he didn't spend more than 10 seconds thinking about it and just put something in there with an expectation that he would change it later. Unfortunately, by putting that 1 megabyte cap in there, that set a hard cap on the ceiling of Bitcoin at about 7 or so transactions per second, maybe 10, somewhere in that range. My guess is if he thought that that was going to persist in perpetuity, he probably wouldn't have done that, but he did. And then kind of as the culture of Bitcoin evolved over the next 5 to 7 years, this really becomes apparent in the block size wars, which was 15 to 17 kind of time frame. And ultimately, the side that won was basically the side that said, you can't introduce a hard fork that breaks the rules of the system. And a hard fork would have meant changing that 1 megabyte limit to something else. And that camp kind of won, and whatever Bitcoin is what it is today. The only ways really to scale Bitcoin that have emerged are ways to compress data, so to fit more data into the same amount of space, which the SegWit thing did in 2017. And then the only other way is really like off-chain transactions, meaning like Lightning, which has not grown very effectively. People have been trying to operate within those constraints for the last 5-6 years, and I'm extremely disappointed, I think, with the aggregate result of that. Not to say there hasn't been no gains, but it's like a 3x gain in 6 years is like, by software standard, pretty bad. Ethereum launched with the same basic proof of work model as Bitcoin for consensus. And then the programming model is pretty different, actually. One of the big things the Ethereum people did not think too hard about that's really creating a source of a lot of problems today is parallelism. In Ethereum, you have this basic problem of, right, you've got all these people all over the world sending transactions to update the state of the system, right? Move money from point A to point B, do this trade, whatever it is. The vast majority of transactions that probably happen within a block, whether a block is milliseconds or even whether it's 15 seconds, or even probably whether it's a minute, probably don't have dependencies on one another. So like a simple example would be if your account balance is zero and you want to send money to Bob, but I need to send money to you first, then there's obviously some dependencies there for that to happen. So chronology does matter. But if you think about most things that happen in the world, at least within the context of 10 seconds or even a minute, probably don't have very many dependencies. You can just make the payment between people. And so the unfortunate thing for Ethereum is the way that the Ethereum virtual machine is designed, they never really tried to deal with transaction parallelism. The challenge here, just in kind of basic computer science problem terms, is you have two people sending a transaction to the system. There's a pretty high probability those transactions don't write to the same piece of the global state at the same time, but you have no 100% guarantee that they won't. And so you need to make sure they don't overlap with each other, because if they do, then you need to figure out which one to execute first. And this has like been a basic problem in computer science for like 30 or 40 years. Basically, the only solution is to like know which parts of the state it's going to touch before you execute it. And then if you see overlaps in what you're going to touch, then you run them serially. Otherwise, you can run them in parallel. Pretty intuitive, not too hard to reason about that in abstract terms. Implementing that in operating systems and such is just mechanically a lot of work. And Ethereum just didn't do it. And the EVM, which is the Ethereum virtual machine, is kind of written that way. And then all of the tooling around the EVM and all of the actual transactions today are all written with that assumption that there is no parallelism in the system. And so the EVM just runs everything serially. So your laptop today probably has 4 cores, maybe 8 cores in it. Your graphics card has probably 1,000 cores in it, maybe 4,000 cores. And you're only taking advantage of 1 core because you're just running everything serially. And so Ethereum, when they launched, I think it was like, call it 10 transactions per second or thereabouts. They've increased the gas limit a few times, which is kind of a very simple way of increasing the throughput. They've got it to call it 30 or so transactions per second by doing that. But there's been real major breakthroughs in the core system. Solana's, if you look at all of the kind of next-gen chains, people have tried to solve this problem. The only one that's really attempting to do intra-shard parallelism is Solana. And this is, if you look at why, it's like, look at Anatoly's background. He did chip design at Qualcomm for a long time, did high-performance systems at Dropbox and some other OS places. And his whole life he spent saying, how do I take an existing piece of hardware and make it go as fast as possible? That's like what he's done for 20 years. And he's looked at, a modern computer and said, okay, how do I make a network of computers all over the world that don't trust each other to just go as fast as humanly possible? The key to that unlock is parallelism. And so Solana runs transactions natively on graphics cards. Modern NVIDIA cards have, call it 4,000 cores. I think the next one's coming up have like 8,000. You can obviously then run 8,000 jobs in parallel. The key, obviously, to be able to do that is each transaction header needs to specify what part of the global state it is going to touch. And so long as the header states that, then the system can line everything up and say, okay, these things aren't going to interfere with each other. So run them all parallel. And anything that has dependencies, you run serially. There's some other approaches to thinking about parallelism that other teams have taken, the most notable of which is sharding. And Ethereum, Polkadot, Avalanche, Near, and perhaps others are all doing and Cosmos are all doing various forms of sharding. What sharding gives you is you get parallelism where you get one thread per shard. So you get parallelism in the sense that each shard gives you a new lane to move forward. If you need to communicate between the shards, there's like a lot of latency and a lot of additional gas cost in doing so. So kind of the key questions I think about like scaling these systems is, can you scale a shard? If you can't scale a single shard, how few shards can you get away with, like on a global scale, to minimize all of the additional latency costs and gas costs that come from cross-shard stuff? That's kind of the basic framework to think. And today Solana runs at like, call it 50,000 or so transactions per second.
So the difference from 7 to 30 to 50,000 is pretty intense. And I want to make sure we keep framing why the technical stuff matters back to like the actual use case and what's important. And so there's a couple other just simple concepts that I want to suss out before we go deeper into how this all works and why it's so interesting. The first thing are some key aspects of just blockchains generally that people seem to care about. One is how scalable they are, one is how secure they are, and one's how decentralized they are. And you said early on that DeFi is the killer North Star, the killer app for blockchains. Maybe we'll start with decentralization. If the goal here is just to get really reliable, super fast, programmable transactions, why does decentralization matter at all? Like, why couldn't just a company start and just say, we're just going to be the trusted source of this thing, and then everyone builds on top of that, rather than try to make it something that is fully decentralized? Walk us through, you've talked about scalability a bit already, we'll talk about security too, but decentralization seems like really a key thing to hone in on here. In DeFi, why have the D? Why does that matter?
So I think there's two-ish ways to think about this. The crypto libertarian angle, which is like what the Bitcoin maxis talk about, and a fair number of the Ethereum people as well, is they frame this in the context of censorship resistance. And they say, look, the only way to make sure the government can never turn it off is to be maximally decentralized. There's definitely directionally some truth to what they're saying. There is a point at which that stops mattering. Because you go from 1 million nodes to 1 billion nodes, at some point along the way, just each marginal node doesn't matter anymore. If you can't turn the system off, then who cares? Oh, node count of X, then why does having a node count of 10X make it better? But that's how I'd say a lot of maximalists and I'd say crypto OGs frame it. The problem with decentralization maximalization is that you end up creating engineering problems of scaling these systems. The other way to think about the problem is what's the minimum degree of decentralization that you need to be reasonably censorship resistant, but even more importantly, I think, is to be credibly neutral. And this is a concept Vitalik has discussed in a few blog posts over the years. It's pretty gray, like what does credible neutrality mean? It's hard to quantify. There's a lot of squishy feelings around it. It's definitely a legit concept. And like Bitcoin is definitely more neutral than Ethereum because the reality is that Bitcoin hasn't changed in like 6 years. The total inability for any one party to meaningfully impact how the system operates is a source of neutrality. Ethereum is less neutral, but I'd say still pretty neutral. The Ethereum Foundation has, I don't say they have control over the network, but they clearly have control over the roadmap. And they are making some inherently political decisions around how to scale the system, new upgrades that go into it, whatever. And there's some degree of human input, right, in politics that comes in that. Solana is at the current moment, I would say, less credibly neutral than Ethereum, but it is becoming more credibly neutral. Probably the best proxy for credible neutrality is the number of parties involved in the system and the degree to which they have influence over it. If you have 1 million people who all have approximately equal amounts of power, that's actually pretty neutral because no one can do anything about it. And so if you look at these ecosystems, today Ethereum feels decentralized. There's hundreds of independent, credible teams doing things around it. There's some folks like the Ethereum Foundation that have more influence than others. And certainly Vitalik and others at the EF, I think, appreciate that they have their voice is a source of privileged power. They are restrained in how they use that. And I think they respect the position that they're in. So when I look at that, come back to your original question of why it's the D in the DeFi, I think it's probably less about censorship resistance and more about credible neutrality, saying, do we all have a playing field that whether you're Bank of America or JP Morgan or a guy in Africa or me or you, can we all agree that this database, this transaction processing layer is credibly neutral, that we all agree on where it is now and where it will be in the future? I think that's probably the important thing.
Can I interpret that to mean that you can reliably build stuff on top of the transaction processing layer and know that it won't change on you later, like the rules won't change later? Is that what you mean by credibly neutral?
I think that's part of it is API support at a basic level, other developer tooling. I think it also means knowing that how blocks are processed, there's not going to be, let's say, too much malicious MEV. I know that's a kind of a technical thing, but that too much malicious MEV. Knowing that someone can't change the monetary policy of the base system is certainly a pretty important source of it. Knowing that like the system is stable and it doesn't have too many bugs and is like going to keep running and not fall over, that's probably a source of credible neutrality. There's probably a few other dimensions to this. I think the most important is that knowing the code will run, but I think there's a few other elements beyond that.
We've gone far enough where I need to pause. I always do this and forget to say, literally ask the question, what is Solana? What's the scope and scale of it today? And just describe how it relates to some of these other things. We sprinkled these in so far, but maybe just to level set before I go off on more sidewinders, just literally, what is Solana? Where did it come from? And why is it interesting to you?
Solana is a blockchain that launched in March of 2020, founded kind of late 17, early 18, is a programmable blockchain. So third parties can write code for it like you can for Ethereum or Avalanche or some of these other systems as well. Bitcoin notably does not really have smart contracts. It is programmable, but in a very, very limited way. Solana is fully programmable in the way Ethereum is. But the big difference with Solana is that from inception, the system was written to go as fast as possible. The way I think about it is, look, computers have aggregate processing ability of X. By introducing bandwidth communications between a group of nodes all over the world that don't trust each other, you are introducing some overhead on X. Your net performance is less than X. Solana's goal is to get as close to X as possible. If you look at Ethereum today, it's probably like 0.01X, maybe lower than that, and Bitcoin is 100th or 1,000th of that. Solana is really trying to get to X.
So if you think about just speed and programmability along with speed as like the service or the function that Solana provides, I guess it's developers, right? What do we think of as developers as sort of the client or the customer of Solana versus client or customer of Bitcoin might be totally different?
That's mostly true, but obviously developers, if you have an idea for some financy application thing, you obviously are thinking about the user experience. Probably the single most important question is transaction cost in any of these systems. And so to a large extent, the customer is also the end users, although the decision is typically being made by an intermediary, which in this case is a developer.
You made this interesting point about how maybe one of the most interesting developments in economics was software itself because of zero marginal costs, and how blockchains are now the first type of software that reintroduce costs. And you mentioned transaction costs there. So maybe just tell that story a little bit. Like, what is this big idea? Because I think it's important to understand why Solana is interesting.
This is pretty well understood today, is that software is zero marginal cost. But look at, I'd say, the world at large until maybe the mid 2000s or late 90s, if you're generous, to kind of internalize the idea of zero marginal cost. That's obviously made for a lot of lucrative software businesses today. And obviously the margins all come from zero marginal cost, and then you can charge whatever markup on top of that. The reason blockchains break that assumption is because in a blockchain, you have a fixed amount of resources. That resource, you have three basic resources. You have storage, you have compute, and you have bandwidth. Those are the three things computers do. And the entire world is sharing some fixed amount of those three resources. Or at least I'd say those things are fixed in the short term. In the long term, they should grow, Moore's law and kind of other obvious things. But at least at any moment in time, those three things are fixed. In the history of software is zero marginal cost because you could always just buy another computer. Or like, even if you wrote crappy JavaScript code as a developer, you send it over to the guy's computer to run whatever application it is on the computer. Even if your code is crappy, the fact that another guy runs the same code doesn't make the system slower for the first guy. There's a new piece of hardware with a new set of programming resources, computational resources to execute that code. Now, obviously, like servers are kind of the constraining factor in the middle here, and servers fall over all the time whenever people get overloaded. And there's been like a whole ecosystem over the last 10 or 15 years that's kind of grown of automating the scaling of servers. And like today, if you do that correctly, like it'll just automatically scale for you. The ultimate instantiation of that is probably Amazon Lambda, where they tell you like, look, literally, you don't think about scaling at all. You just write functions. And so that's just been like a common theme in kind of the history of software for a very long time. Blockchains, you have a fixed amount of resources, and everyone in the world has to share them. That's just like a new basic economic model for how to think about the world. And so the only way to deal with metering and spam and transaction priority, and even a fixed amount of resources, is to have some non-zero costs to using the system. And then that has other interesting implications as well, the most notable of which is what I like to call anti-network effects, which is that if you look at these systems, there's been a couple of blog posts written about this, although I can't find them. But if you look at, people complain about Ethereum gas fees today quite a bit. But if you look at it, if the system is below, call it 50 or maybe 70% of total throughput, the gas fees don't really move much, like going from 25% utilization to 50% utilization. Gas fees move up maybe 1 or 2 or 3%. It's not much. But then when you get to 70% and start going from there, it like increases a bit. And when you get to 90% utilization, every marginal percent increase in demand, fees go up like 10x. And so you get kind of this exponential looking curve as you approach 100% utilization, which is actually pretty intuitive because some transactions are higher value than others. And so people are willing to pay more to get those included. But obviously that is the definition of anti-network effect, which is it becomes worse for all of the other people who use the system. And so this is kind of a new economic concept in these blockchains that hasn't really existed before. And I don't think the world is fully internalized all of that. When you see people complaining about gas costs, they are implicitly acknowledging this. But I think it's helpful to frame it in a different lens, which I call anti-network effects, which I think the key distinction there is then also when you call it anti-network effects, you are projecting forward and saying, if demand keeps growing, it keeps getting worse and worse and worse. The nature of the problem is one that it gets worse as demand grows.
So as we think about just the basics of what a blockchain is, I'll go back to Bitcoin just to keep it simple. Every 10 minutes or so, you've got a block, which is basically like a new record of transactions that updates this global database of who owns what Bitcoin, what wallet addresses own what Bitcoin, what public keys. And that's basically it. And the way that you get the right as a miner in Bitcoin to create the next block of those transactions is spend electricity. Basically, you're guessing hashes and one of them is right and it unlocks it. And that's just a compute power question. And it's this really clever system for how we're going to all agree what the next set of transactions are and sort of put them into a global state that we can all agree on, which is just really cool. What then matters, it sounds like, is neither Bitcoin or Ethereum has solved the problem that if we all have to agree, if the whole world has to share resources versus adding resources, like you said, in software, then all of a sudden there's a big problem if these things get popular because it gets too expensive, whether it's gas fees or something, any kind of transaction fee becomes too expensive to change this shared state of who owns what on the ledger. So how does Solana solve this problem, like from a technical standpoint? If it's not proof of work like Bitcoin or Ethereum is today, how the hell do we go from 30 transactions per second to 50,000 transactions per second and have everyone agree and have the thing actually work reliably?
There's three basic primitives in a computer. You've got storage, bandwidth, and compute. Storage is mostly not an issue. I mean, you need to read and write from an SSD. You obviously need to design the nature of the reads in like the database locally to be as fast as possible. That's like Oracle and SAP and Microsoft. And there's a million database companies that kind of do that stuff. That's a pretty well-known issue. And obviously that's by definition localized to a single computer. The more interesting ones to think about are bandwidth and compute. If you look at Bitcoin and Ethereum at the network layer, they both implement what are called gossip protocols. A gossip protocol is actually what you think it is. It's, hey, my computer receives a transaction. I acknowledge I've received it. And then I rebroadcast that transaction to all the other nodes that I know. And then those guys do the same thing. And so you literally just get like a spiderweb blowout effect as people do that in real time. The great thing about gossip protocols is they're extremely resilient. Random nodes can just go offline in the network anywhere. And it doesn't really matter because like as long as enough people are connected to enough people, the transactions get rebroadcast to everybody. The downside of gossip protocols is they're extremely inefficient. Everyone just randomly rebroadcasting to everyone else is like obviously not efficient by definition. Solana uses a networking protocol they call Turbine. And Turbine is basically inspired after BitTorrent. It looks a lot like BitTorrent actually. And the idea is, hey, look, in any proof of stake system like ETH2 and like Solana and others, the set of nodes that are in the consensus group are known ahead of time. Let's say there's 1,000 nodes. If node one, number one, receives a transaction from a user, then they basically, instead of rebroadcasting that randomly to the 1,000 nodes, they rebroadcast that to nodes 2 and 3, then rebroadcast that to nodes 4 and 5. Meanwhile, that's going in an exponential curve to a known set of nodes within kind of a hierarchy. And then meanwhile, you'll also, that node will send the transaction to node number 1,000. Number 1,000 will send it to node 999 and 98. And then those guys also live within this hierarchy. And so there's actually a hierarchical relationship of all of these nodes, and they all know where they are in the hierarchy relative to the other nodes. I don't mean hierarchy meaning control. It's not that any node controls the other. It's just simply ordering, so that you can most effectively rebroadcast data between all of the nodes as fast as possible. The mechanism they use here is just log2. This is a very common thing in computer science and searching algorithms and data broadcasting algorithms. BitTorrent looks a lot like this as well. And so they just took that basic methodology and applied it here. And it's known to be kind of the fastest way to propagate data, a whole bunch of nodes. So they implemented that. The other basic limitation you have to deal with is compute. And by far the most important variable here is serial compute versus parallelism. You just get 1,000x plus gains from that. The other important thing about serial versus parallelism is to not only look at where the world is today, but also then think about what's happened in the last 10 years of silicon and what's going to happen in the next 10 years of silicon. If you think back to the late 90s, early 2000s, computers, the clock speed was improving at a really fast rate. And this kind of peaked, I think like the Pentium 4, which was like early 2000s, was kind of the peak of the clock speed wars. I mean, it got up to about 4 gigahertz, maybe 4.5 gigahertz or thereabouts. And then they like stopped getting faster, call it around 2005. If you want to be generous, let's say 2008. And if you look at just go look at laptop reviews or desktop reviews for the last 12 years, you notice is that the headline clock speed has not increased at all. The reason it hasn't increased is because heat dissipation, or I should say heat creation, and therefore the need for heat dissipation increases super linearly with clock speed. I'm not like close enough to silicon to explain to you why that's the case, but just like as the transistors switch faster and faster, the heat becomes the problem. And so basically fans computers, so desktops primarily and laptops to a lesser degree, kind of have topped out at about 3.5 or 4 gigahertz or so. And then if you look at fanless devices, so notably your phone and like your iPad, those have capped out at, call it 2, maybe 2.5 gigahertz. They just don't go any higher than that because you have heat problems. And that's been true for like a decade, if not longer. Where have all the gains come from in computes? They've come from making each process cycle a little faster. There's been some gains there, but certainly nothing close to Moore's law. They've come from parallelism, which has been huge, and modern cards are massively parallel. And then they've come from chip specialization. So like if you look at your iPhone, for example, your iPhone system on a chip has like 100 different sub processors on it that like do camera stuff and video stuff and microphones and whatever. When we think about the next 10 years of compute, these are not really specialized compute functions, not like camera functions or video functions. The most generalizable way to think about scaling that is just parallelism, because as you increase the number of cores at a fixed clock speed, the heat creation doesn't increase super linearly. And so we've been able to scale parallel. That's exactly what Solana does. And that's how it gets this massive gain relative to its predecessors. But then more importantly, it also then gives you a forecastable path on which, if you're writing code today, you can say, look, in 5 years' time, in 10 years' time, I can reasonably believe aggregate throughput will be 10x or 100x or 1000x, whatever, based on current trajectories of how silicon is working. There's a lot of great stories about, I think probably the most famous story like this is Netflix, where Reed Hastings wanted to do streaming, at the time of starting, but like knew that the bandwidth wasn't there. And they were able to do the math in like 2002 or whatever, and sort of calculated like, oh, okay, bandwidth is getting there. We can do the streaming thing. I think they look at this as kind of a similar type of problem space.
This is really fascinating. If we think about Solana as the one blockchain that is sort of riding this updated Moore's law, which now I understand is being driven not by single threaded advances, but by parallel advances. So we know a couple things. Solana already is way faster because it can take advantage of parallelism, but also it gets to ride that wave. So with ones that are relying on serial single threaded improvement like Bitcoin or Ethereum, maybe the scalability is going to go up, but you just can't be confident that it will. So there's sort of like a future proof that Solana has. It begs the question just one more time, and I may have just have missed in clicking for me earlier, but since this is so critical, it's like the key advantage. I want to make sure I understand why Solana is able to take advantage of parallelism while the others are not. So what about the system? Is it proof of history? Maybe it's time to explain that. Why is this possible in this one instance when it's not in the others?
So this is just a function of designing an execution layer for writing code that has nothing to do with consensus algorithms or proof of history. It's harder to build systems that support parallel transaction processing, right? Like, remember Intel launched the Core 2 Duo, the first dual core computers, and then the Athlons in probably 06, 07 timeframe, maybe 08, right around then. And it took like 3 or 4 years for Microsoft and Apple to like get Windows upgraded and Mac upgraded to support that. It was just really hard, sort of like low level resource management problems and stuff for all of these things. Today, those are like all solved problems, but it just like took a really long time and it was just really hard and painful. And there's just not that many engineers in the world that like know all that stuff. The easy thing to do is just write everything to run serially. The history of software up until call it 08 was like everything was basically serial, other than a few things in graphics card land. And the same is kind of true here. So it's just a function of designing a execution environment to take advantage of that is the primary difference. Look at the backgrounds of the people who built the core systems. They got nothing against the Ethereum team that kind of built Ethereum V1, but they just weren't distributed systems, high performance operating systems guys. Like that just wasn't their backgrounds.
So what is proof of history? Why is that relevant? Why is that a key innovation here? You talked earlier about how often there's not dependencies, so the exact ordering of transactions in time may be less relevant, but there certainly are scenarios where that is the case. And if you want ultimately a blockchain to be like a record of value that we all agree on somehow, which no doubt that would be useful, as fast and reliable as possible is really important. So how does proof of history figure into the story here relative to something like proof of work?
Most important comment, proof of history is not a consensus algorithm. Proof of work and proof of stake are also technically not consensus algorithms, although they are closely related concepts to consensus algorithms. But I want to make sure I use the correct terminology here. Proof of work is a Sybil resistance mechanism, where the idea is you've got people all over the world who are claiming they have compute power or whatever. The only way to prove that you have the compute power you have is to do the work and to produce a proof that you did the work, which is running those hashes over and over again. The consensus algorithm that Bitcoin and Ethereum currently use, or I should say that family of consensus algorithms, is called Nakamoto consensus, invented by Satoshi Nakamoto, where the simplest way to state that would be the chain with the most accumulated proof of work is the canonical chain. People often call Nakamoto consensus proof of work for simplicity. That is oftentimes shorthand used, but proof of work is technically Sybil resistance mechanism, and Nakamoto consensus is the actual thing. Proof of stake is also not a consensus mechanism. Proof of stake is a Sybil resistance mechanism, where the way to prove you have voting power in the system is to have coins and to stake the coins, where the coins themselves are that mechanism. Basically, all of the proof of stake consensus algorithms, all of the major proof of stake blockchains use a family of consensus algorithms that are called classical consensus algorithms. And the most popular of those is called Byzantine fault tolerant, or BFT, which was invented again like 20 some odd years ago. Solana also has introduced a notion called proof of history, which is not related to consensus, but is one of the kind of interesting innovations in the system. And it's specifically designed to do a few things. All of these blockchains are kind of funny in that they don't really have notions of time, or I should say they have very challenged notions of time. If you think about, like in Bitcoin, the system updates every 10 minutes on average when a new block goes out. In Ethereum, it's like every 13 seconds or something. But in between those moments in time, the systems aren't updating. There is no quote unquote passage of time as far as the system is concerned. Proof of history is a way to get a much more granular source of time embedded into each block without actually having all of the computers all over the world talk to each other. And given the inherent latency of the speed of light going around the planet, you really can't get blocks under 150 milliseconds, and that's probably generous, probably too aggressive, but maybe 200 milliseconds is like the best you could ever do. And so proof of history is a way to encode the notion of time into a block. And so what proof of history is literally is just taking a single input and running a hash on that, and then taking that output and running a hash on that, and then taking that output and just repeating that over and over again. The beautiful thing about that process is that you cannot parallelize that process, because the output of each hash is the input to the following hash. And because you can't know the output in advance, there is no way to run that in parallel. What does this give you? This gives you some interesting properties. One, it lets you order transactions within a block, because you now have a notion of time even within the context of each block. If you look at how Solana blocks are encoded, they have these hashes running, and then every time a transaction shows up, it gets inserted into that hash system. So you get more granular notion of time. The other really interesting thing, though, that this does is this kind of gets down to lower level message propagation and consensus. You've got all these nodes all over the world all talking to each other. Sometimes the internet's not reliable. Like packets get dropped. They don't make it places. Maybe they make it to where they need to go. They just don't get there as fast as you want them to. If you've got the system updating every 400 milliseconds, you've got 1,000 nodes all talking to each other. In order to finalize a block in proof of stake systems, you have to have 2/3 of the stake agree on the current state of the system. It's quite frankly not ever going to happen that you're going to get 1,000 nodes to all agree on the system every 400 milliseconds as it's updating in real time. You have to have happen in these systems is you have to have the ability to say, look, this block has happened, this 400 milliseconds has passed, we're going to move on to the next 400 millisecond period, but we all haven't actually finalized the last block, but we all need to know the system's going to keep moving forward anyways. If you want to do that, you need to have a clock that everyone can agree on. There is no person in the system who controls the clock and maintains the clock. And by definition, the problem you're solving is you can't wait around for everyone to talk and agree about the time. So how do you do that? And that's kind of what proof of history is. And so the idea with proof of history is everyone is maintaining their own clock, running those hashes. In Solana, they actually don't call them blocks, they call them slots. Where a slot is, I don't remember, but I'm just going to say it's 1 million hashes, just running over and over again, which approximates to about 400 milliseconds in human time. And the idea is everyone around the world who's running Solana knows that every 1 million hashes, the system rotates to the next person. If you are the next person, let's say, and now you're in your 400 millisecond period, or I should say your 1 million hashes period is yours to be the leader. And if you just don't respond or whatever, and like don't communicate, then everyone is running their 1 million hashes. They all just know to skip you, and it just goes to the next person. So what this does is it provides a very elegant mechanism for skipping for people who are just not there, because everyone is maintaining their own source of time. And then whenever the next person does show up and does respond in time, then everyone can resynchronize. You have to assume some degree of drift, because all these clocks can't be running perfectly at the same speed. These clocks are constantly drifting apart and not being perfectly synchronized. And every time everyone comes to consensus and agrees, they get resynchronized to that hash, basically. And so that's what Solana, that's what it allows you to do, is if you want to get the block times down really low and still be able to rotate leaders every few hundred milliseconds, you need some way to have a more granular notion of time that doesn't require everyone to talk to each other.
There's one more big concept that I want to pile through before we talk about what all of this enables. I know we're doing a lot of technical stuff, but I just think it's super interesting to understand what is behind this system, which might then enable everything we'll talk about in sort of the second half. And so the way to think about this second batch of questions is around the supply of Solana, the actual currency itself or token or coin, whatever you want to call it. And again, I always try to analogize back to Bitcoin because it's simple to understand. So there's going to be a supply of 21 million of them. We know where they come from, meaning they themselves are the reward for the security provided by miners running all these hashes to make sure this thing is locked down globally. If you want to earn Bitcoin that way, you have to be a miner. And we kind of know how many there are going to be. It's very simple to understand. Anyone can get that. And if we all agree they're valuable and there's a fixed amount of them, there's the price. With Ethereum, it's a little bit different. There's 100 something million of them. Maybe there's going to be more that come for as mining rewards. Maybe there'll be less because they'll be burned. Again, a little bit of an uncertain future. So that brings us to Solana. Like, how many of these things are there? How many will there be? What determines who earns them and how they earn them? Just give us the same story for Solana that I sort of laid out for Bitcoin so that people can wrap their minds around it.
Solana's Genesis block was 500 million tokens. I forget the exact distribution of them. I do know the largest segment of that distribution is what was called just community, which really just means the Solana Foundation is holding those coins. Note that that is separate from Solana Labs. The intent is to use those coins to promote the growth of the Solana network. I want to say that that bucket is something like 20% of the total supply. It's at this point a pretty large dollar number. I think the probability that the Solana Foundation will ever put that to work is zero at this point. I just don't think they can spend that much money, even if they wanted to. And so I expect at some point, like, they're just going to burn a ton of it, but that's not anytime soon. And I have no insight on if or when that will happen. I just don't see how they're going to spend $20 billion. There's an inflation rate, just like there is in all these other systems. Solana, much like Ethereum, has perpetual inflation. The inflation, I believe, was set at like 7%, and then it decreases over the first 10 years down to something like 1.5%. And then much like Ethereum just turned on with EIP 1559, where a part of every transaction fee is burned, Solana actually has had that same mechanism live since the network went live. I'd say in terms of monetary policy, Solana looks quite similar to Ethereum.
And then why do people want to own it and hold it? What is the value of, let's say, owning SOL in a portfolio? What can you do with it? This is where the concept of something getting locked in DeFi, which is a phrase that if you don't know, it probably means nothing to you and we need to explain. But what is the motivation to actually be an owner? If there's 500 million of these, I'll call them an asset. Each little one's an asset. Why would you want to own any? And what can you do with them once you own them?
Some of the Ethereum people have written some excellent work in the last 12 months on this. I think the Bankless guys may have coined this term. They call it ETH a triple point asset. I actually think it's probably more than a triple point asset. But if you've read any of that writing, all of it maps over to Solana one for one. So let me break them down, though, here briefly. So one is you have to use these to pay gas fees. So you need them as a commodity, much like you need gas in your car. Two is there's this burning component. So these assets could be deflationary as transaction volume grows. And so you could potentially have an asset that gets scarcer over time, which is very interesting and basically hasn't existed in human history. There's really never been an asset that's credibly getting scarcer. ETH nor Solana are there today because the demand is not consistently high enough to sustain that, but it's at least plausible that we have that kind of an asset. Three is a very trust minimized source of collateral you can take with you anywhere in the world, and then you can lever it up and do other things with it, which is interesting. And then four, you have a native staking rate, which is effectively acts as the risk-free rate in these systems. The US government is risk-free rate for dollars, and so ECB for euros, and so on. All of these proof-of-stake systems conveniently have these staking mechanisms in them where you receive inflation. I don't mean to suggest risk is zero in these systems, because that's definitely incorrect. But obviously, the risk-free rate of these respective systems is the staking rate. And so you have that very interesting monetary angle to them. And then the last, and this is probably the most important, is these things are non-sovereign stores of wealth. The Bitcoin people will pretty strongly push back on that claim. The Bitcoin people will say it can't be a store of wealth because it's inflationary, because it's not as neutral as Bitcoin, because it's weird and new and does too many things. And then the right thing to have in a store of value is simplicity and unchangingness and all that stuff. They're not wrong in making those claims. But I think the problem with that kind of worldview is it's just fundamentally a backwards facing view of the world, saying, well, the best store of value was gold. Therefore, the digital version must look as close to gold as possible. What the internet has taught us in the last 20 years is analogizing things from the physical world to the digital world perfectly is almost always the wrong answer. And I'd say my optimistic view of these things is, if you look at so you look at just global asset around the world, gold is like 10 trillion or something. And like all of the other wealth in the world, other than a few other commodities, is more or less productive assets, right? So debt, equity, and real estate being the largest asset classes, those account for, 800 trillion, 900 trillion of wealth around the world, something like that. Pretty obviously, the world likes productive assets, and pretty obviously, the world doesn't really like non-productive assets, and like by like a factor of 100 to 1. And I think the other thing is if you assume we're in a world in 5 to 10 years from now in which there are a billion people using one of these platforms, and it's got DeFi and social tokens and NFTs and games and whatever, all this stuff. And you've got Bitcoin, and it's like, look, man, there's like 300,000 transactions per day. It's like a settlement layer because you move it between Coinbase and Binance and the ECB and the Fed. It's a settlement layer thing. I just think most people in the world are going to like be like, yeah, man, the one that like all the apps are built on is like the one I want to own. And that just seems fairly obvious to me, right? Like it still doesn't feel that way because none of these things are still like that mega scale in consumer adoption. But if you assume there's something out there or some series of things out there that get you to that kind of scale, then I think there's like the perception is just like, yeah, man, that's the boomer coin. Here's the new age thing that everyone's using. I think the Bitcoiners generally are too prescriptive in the nature of what does it mean to be non-sovereign store of wealth. And I think, and if you look at all of these blockchains, Bitcoin, Ethereum, Solana, Zcash, whatever, all of them have that kind of fundamental property. The monetary policy cannot easily be influenced by humans. I agree it takes time to prove the degree to which that statement is true, and it is a non-trivial claim to make that no one can manipulate that in the future. But today, Ethereum's monetary policy is pretty damn credibly neutral. It's not as perfect as Bitcoin's, but it's pretty close. Solana's today is not as good as Ethereum's, that's for sure. But in like 2 or 3 years, it very well could be. But it's not going to take 20 years to get there. So I think what matters as you think about non-sovereign store of wealth is really just predictability of monetary policy. And you need to get that to probably like within 1% annualized is probably fine. And then if it's a productive asset, if it powers all these applications, it has a risk-free rate, it has this burning element to it, has all these other things going for it. In my mind, that is kind of what ultimately is the biggest winner in crypto, is this new age, digital native store of wealth that's non-sovereign that also happens to power all these amazing applications.
I really love the concept. I remember in my 20s reviewing every asset in the world and trying to figure out what I wanted to own as an investor and realizing that like all the stuff like gold that you think of as an inflation hedge is not as good at that as equities are, just because they are productive and they adapt to the changing world. And it sounds like Solana is sort of the stock to Bitcoin's gold, if you will. And it begs the question, okay, if Solana we've come a long way to basically say this thing is way more scalable, way easier to work with because transaction costs are way, way lower, but maintains many or most of the same properties that make like a blockchain and this idea of censorship resistance and neutrality and all the things you talked about helpful and useful. Now we need to get to the part of the story, which is, so what's going to get enabled by this? Like what kinds of applications? I'd love to talk about DeFi. I'd love to talk about other applications outside that, whether it's gaming or elsewhere. What does this allow for that was previously impossible, either in centralized systems or in Ethereum, that makes Solana so exciting? What does it bring to us?
So the first and most important application probably built on Solana is Serum. Serum is technically not an application. It's really a piece of infrastructure. Serum was built by the team at FTX and Alameda, which are run by Sam Bankman-Fried, who's well known as CEO of FTX. Sam got real excited about DeFi in April, May of 2020, kind of right as DeFi started to really take off. And he like wanted to build an order book on Ethereum and was completely unable to do so and got really frustrated. I said, okay, I'm going to go look at all these other new blockchains and figure out which one can I build an order book on. Looked at all of them and then concluded Solana was what he wanted to build, where he could build one. And so Serum is that. Serum is a fully generalized framework to run an on-chain central limit order book. And that order book can power spot trading. It can power derivatives. It can power interest rates. It can power sports betting, anything. But it's a generalized framework to power all that stuff. Today on Solana, there's probably between 5 and 10 exchanges that are live today. Probably the most notable of them is called Mango that use the Serum framework. And there's probably 10 or 20 or 30 more teams today building on the Serum framework to build various exchanges. But the core insight there is that the central limit order book is the foundational pillar of finance. And like for anyone who's traded in equities, that's pretty obviously how they all work.
Just describe that for anyone that doesn't know why that's the central concept in finance.
What is an asset worth? The answer is what people are willing to sell it for, what people are willing to buy it for. And there's a spread between those two things. And you've got a lot of market, if you go look at NASDAQ or New York Stock Exchange or whatever, and you look at those matching engines, it's just a bunch of market makers putting offers on the book that are higher than the bids and the bids lower than the offers. And they make a spread when people cross the spread. And obviously, this is how the vast majority of equities trade. Bonds trade in the same way, but they just don't trade on an order book. They just trade like weirdly on like banks' balance sheets and like OTC, and it's crappy. But actually, the bank is doing the same thing. They're just quoting bids and offers to buyers and sellers. Same thing. That's like how price discovery happens, is that mechanism. Ethereum never could do a central limit order book. If you actually look at the history of Ethereum, The first real application that took off on Ethereum was called EtherDelta, and it was an exchange launched in late 16. And they like played all kinds of weird games and tricks to like make the system work on Ethereum, but it was just slow and crappy and the gas fee sucked. It was just a very primitive thing. The next major application that took off was a protocol called 0x, which was a smarter way to trade on Ethereum, but it required having exchanges that are off-chain host a matching engine, and whenever trades match, to send the matched order to the blockchain, and the blockchain would settle the trade. It was better, but it had all kinds of problems. Ultimately, the model that worked on Ethereum, given the both gas cost and given the block time, meaning 14, 15-second blocks, was the Uniswap model, which is this model of having automated market makers. The only reason automated market makers even had a chance of working, by the way, is because the fees are really high. The spread is 30 basis points on Uniswap, which is, if you guys win the NYSE or NASDAQ, it's at 30 basis points, like
tell you to get the hell out.
Like the future of finance is not 30 basis points trading, like it's sub 1 basis point trading. So the inside of Uniswap was you can set the fees really high. Some set of market participants they're not fee sensitive and don't care. And if it allows you to work in a decentralized setting, you can kind of unlock a new set of users and markets. That was obviously not intuitive to the world before Uniswap took off. And we missed it in a very public, painful way. But I've come around to kind of realize it was an interesting innovation. Uniswap worked because Ethereum was slow. Specifically, it worked because Ethereum was slow. The point of Serum is if you have a fast blockchain, you can run an order book on chain, and that's what Serum is. I went live in August of last year, and today there's like a whole bunch of people building on Serum, building all kinds of different financial products. So I think that's the most important breakthrough application that like really doesn't work on Ethereum. I think the other stuff beyond just Serum is just thinking about, I'll point to things that are either live now or are known to be public. So one is Audius. Audius it's kind of a censorship resistant SoundCloud. It's not really Spotify. Artists aren't dropping albums on there, and because of how publisher rights work with record labels, they're not going to drop albums on there anytime soon. But artists who want to just drop like a track, they like made a remix at home or a track at home, and they want to distribute it to their fans, they can put it on Audius, and Audius acts as kind of a new age SoundCloud kind of a thing. Audius today, primarily in the electronic music community, it's actually pretty big in that community now. There's about 5 million or so monthly actives. If you want to have something like Audius work, you want to have the idea of likes and who's played which songs and history and what your friends have listened to. Obviously, you want to have all those kind of features. If you want to make that all work in a credibly neutral way and not be tied to a centralized platform, you need to run this all on a blockchain. So Audius could never run on Ethereum. They launched on an Ethereum sidechain back in 2018 called POA Network. And they earlier this year transitioned to run on Solana. And so today, if you use Audius and listen to a song, every time you hit the play button or a like button or whatever, all of those are getting logged on Solana. At 5 million monthly actives, there's no chance this would ever work on Ethereum. So that's like a very simple application. But then if you kind of start to extrapolate from there and say, okay, well, now you want to have artists issue NFTs and social tokens and all that stuff. Audius team has publicly talked about NFTs. I think like a few weeks ago, they announced it. But you can imagine, artists who have millions of fans, you can imagine they're all going to spam this. You do an NFT drop or something, you're going to have thousands of people, if not tens of thousands of people hitting the system all at the same time. You're just going to need throughput to support these kinds of use cases. If you think a little bigger than that, I think a really exciting idea is kind of looking at games. There's a game that's been announced for Solana called Star Atlas. The token just launched a few weeks ago. Star Atlas is basically EVE Online, but like all the assets in the game are owned by someone. Never played EVE Online, so I can't speak with a high degree of precision about it. All of the ownership rights are encoded on the chain. And so you get this degree of credible neutrality that comes from that. And then also, by definition, you make it so that the game itself is extensible, where any third party could build extensions onto the game, or I should say onto the state of the game, without the explicit permission of the developer. Is that actually interesting? I don't know. Maybe it's not more interesting than EVE Online is on its own. We'll see. But that kind of an idea, EVE Online has millions of players. You're just not going to do that on Ethereum. And you can kind of extrapolate this concept into, what is a term that's now overused. People call the metaverse. And the idea is kind of like, you've seen Ready Player One, kind of that idea. So I think those kinds of opportunities all need something that looks like Solana. I think the last thing I would say is one of the kind of common memes that's come around over the last 12 months or so has been kind of the financialization of things like the meme economy. We saw this with kind of GameStop and AMC and others. And now we're seeing this with Dogecoin and other things. And I think the more interesting thing that's happened here is AMC recently announced that if you own AMC stock, you can get some free popcorn at the movie theater. It was mostly a gimmick, and like the execution of it's actually extremely poor. We had a bunch of our employees go to various AMC theaters and test this out. Yeah, and try it. Turns out the guy at the store was just like, yeah, here's some free popcorn. And like the verification process was like so cumbersome and miserable that the employees don't enforce it in any meaningful way. But conceptually, to me, I think that's like the first example of a much bigger idea in capital markets and capital formation of like using ownership to unlock real world things. I could totally see a world in 5 or 10 years in which that idea is much more commonly used by companies. And if you extend this idea of the financialization of the world a little bit further, it's just like, can you put finance into social interactions? Yeah, anything. It doesn't have to be Reddit or Facebook or Instagram. That's kind of what people commonly think of. But it could just be anything online. That design space is large enough that it's almost certain the answer is yes. And there's a whole bunch of smart people today playing with early versions of those ideas. And again, I think those are only really possible on something like Solana.
You mentioned the concept of social coins or social currencies a few times. Just riff on that for a minute, kind of what you mean and why that might be interesting.
Today, you've got people like, I don't know, Bieber, you got LeBron James, you got Tom Brady, whatever. Their brands have some value. They sometimes monetize their brands with commercials and sponsorships and stuff. So people have come up with the idea of just, what if you just made yourself into a meme and just made yourself into a coin? It's a very vague statement, but it's like a very interesting thought experiment of like what happens in the world if all of a sudden everyone has their own coin. There's a bunch of people playing with this idea right now. But the basic idea of them is that like you can just design a system that says the price of a coin starts at X, and then every time someone wants to buy the coin, like when you buy the coin, the dollars go in the reserve. And then the next person wants to buy the coin, the price increases, and the reserve can always create new coins. And you can define a formula for how the price changes over time. And the reserve itself is always solvent and always has enough money to buy back all of the coins if everyone wanted to sell them all at one time. So you have basically just a programmatic market maker that operates on some defined formula. And so the idea is you make it trivial for anyone to issue a coin. You have inherent liquidity and a market maker built into the system based on these concepts. Like, what do people do with them? What's nice is if you put this on a blockchain, you can also tie this programmatically to future monetization. So you could say, I'm an artist. Hey, I'm going to give away 10. If you own my coin, 10% of the revenues from all my artwork sales are going to flow into buying my coin, right? And you can literally prove that programmatically on chain. That's like a very simplistic way to do it, but like you can do stuff with that. There's obviously a lot of opportunity for fan clubs and community engagement and join my Discord and those kinds of things. There's opportunities for, hey, get at the top of the list for my next concert. I could totally see creators collaborating and saying, for example, look at like these TikTok hype houses. If like, imagine if all of those guys have their own coins, they could say, hey, if you own X number of coins for each of the people in the hype house, you can come do a video with us and like be in our TikTok. I can imagine that's going to spawn new sets of creators that will, hype house influencers that'll get born out of that kind of mechanism. It's a new tool for creators to use in their monetization tool belt. Combine this with the intersection of NFTs, whether that means art, whether that means just encoding a video they made, selling it, whatever. But those two things to me seem very naturally to go hand in hand with each other. I think they're going to be very, very widely adopted in the next 5 years, primarily by the TikTok, YouTube, Twitch class, and then emanate outwards from there.
How do you think about regulation in all of this? So some of the things you mentioned, like tying future value into a treasury or something, starts to sound very security-esque. And whether or not something is a security is a critical binary for the pace of innovation, what's allowed, what's not. Obviously, most regulation exists for reasons, even if it gets out of hand. How do you think about regulation and the security problem in the entire Solana ecosystem?
This is not really a Solana specific question. This is an industry question. One outcome is this doesn't happen in the United States. It only happens elsewhere. And that's a really sad outcome, but is a very real possibility. I'd say that's probably the base case right now. I'd say most people in the industry are operating under. There's another case that this becomes so widespread and so popular so quickly among so many young people that don't care that the SEC is forced to kind of reconcile it. This actually already kind of happened with ICOs and DeFi. The number of ICOs and DeFi was like, look, there was like, 100 or something DeFi protocols that matter, but there weren't a million DeFi protocols that matter. If this takes off and it takes off in the right ways, you could totally see enormous number of 25 and under creators doing these things in like a matter of 30 days. It could be a crazy new thing. And if it happens that quickly and they all just don't care, you're all protected by the masses. So that could happen. I'm not suggesting that should happen, but it seems pretty possible. A third is just that it kind of happens slowly and the SEC finds it to be okay and gives you some safe harbor. I say that's a pretty unlikely, at least under a Democratic administration, but you never know. So I think those are the three most probable ways this plays out. The thing is the temptation for creators to experiment here is going to be too high. I think they all know that they're under monetizing. And so I do think that given that reality, it has to happen. It's just a question of, does it happen here or does it happen elsewhere? And then if it happens here, exactly how does it happen?
Back to Solana, if we start to think about the future and there's just obvious difference between what it can do and what it enables in others, nothing's going to stay static. I'm sure other layer one blockchains will emerge. How do you think about, I guess this is a Solana specific and a general question, how do you think about competition? You're an investor. You're first and foremost putting capital into projects, whether those be currency projects or companies or whatever. As an investor, how do you think about the future of competition to Solana or other layer one blockchains, generally speaking, given that innovation keeps moving? And we might be saying the same thing about Solana today on some dimension I can't think of right now that makes it look childlike, like Bitcoin looks childlike relative to Solana.
There's known risks and there's unknown risks, right? There's known unknowns and unknown unknowns. Unknown unknowns are kind of always the gotchas in the world. Doesn't matter how smart you are. I think the probability as it pertains to layer one blockchains that there are unknown unknowns at this stage is pretty low, like sub 5%. The mechanisms for distributed systems are understood. Cryptography is understood. Programming models and programming languages are understood. I'm not worried about something can always change in computer science, but like, man, it's really hard to reason about that today. There are a handful of known unknowns that are definitely interesting and the ones I think about. If you look at how the alternative mechanisms of scaling, there's like 3-ish ways to scale a blockchain. Then there's like some sub-dimensions within each of those 3, but the 3 are make the system basically just more performant at layer 1, which is what Solana does. And there's a bunch of ways to do that mechanically. And Solana is by far leaned the most into that of all of its peers. The other is sharding. The third is rollups. Let me touch on sharding first before I hit rollups. So sharding versus single shard scaling. My intuition on this is that these things are path dependent. Sharding by definition doesn't make sense until you have maxed out the capacity of a shard. And like, we're not close to maxing out the capacity of a shard today. And I have a pretty reasonable path to continue to grow the single shard now in the form of Solana for at least the next few years. I actually am pretty concerned that demand will outstrip supply for Solana by a large factor in the next 5 years. But I also know that the world is path dependent. And so being the thing that can get you to the first 10,000 TPS matters. And then you'll deal with how to get to 1 million TPS after that. But saying you're at 30 and then you're going to get to 1 million, you're not close enough yet to people take you seriously. I find sharding to just be out of order in terms of order of operations. It also just creates a lot of other problems. They're all solvable problems, but just creates annoying problems. Rollups is probably the more interesting thing to think about. The Ethereum people have been talking about rollups for a while. There's 2 flavors of them, optimistic and zero knowledge. Optimistic rollups I find to not be intellectually interesting at all. They like get the fees down from like call it $50 to call it $2 on Ethereum. They have absolutely no credible claim of getting the fees down to 10 cents, let alone a fraction of a penny. And today Solana is in the fraction of a penny, like 1,000th of a penny or 100th of a penny or something. I just don't think any big business, anyone who's actually thinking about large scale is even remotely going to consider $1 plus. I'm really afraid 1,000th of a penny is too expensive. What if we need to be 1,000,000th of a penny? But like $1 is just not even on the table. And so the other approach is the zero knowledge approach. And that has a real path to getting there. The challenge with all the zero knowledge stuff is very, very few people know how it works. It's literally encrypted blobs that like no one, like you just can't go read the data. Like it's just encrypted blobs of stuff. There's no education in academic programs around the world that teach people how to build these things or program in them. And it is really complicated. And it introduces other new trust vectors in these systems that are just weird. But most importantly, they're like just generally not programmable. They're not like fully composable and open and understood like the rest of all of computer sciences, more or less. And so the kind of question we've debated this internally is if you're long Solana, are you short zero knowledge proofs? And that's like too binary of a way to frame the question, but it's like directionally an interesting question to think about. My sense is the zero knowledge stuff is there's a chance that it's never good enough to be fully general used by the whole world at large. That's definitely a probability. If it is, in fact, we'll eventually get to that point. The question is when, and is that 12 months away? Is it 36 months away? Is it 7 years away? Those are all possibilities. So your original question was, how do you think about risk and known and unknowns? The biggest known unknown is zero knowledge rollups for sure. The nice thing is zero knowledge rollups can run on Solana. Like there's no reason that they can't. And in fact, they would be better on Solana than they would be on Ethereum. You can just take all that same stuff and reapply it. My assumption is that if you're going to get to a world where you have 1 billion daily active users who are each producing, call it 100 transactions per day. So you've got 100 billion transactions per day going through the system. I think the only way we're going to get there is zero knowledge stuff on top of Solana. That's my mental model of how we get there. And probably the highest probability path you do to get there is you max out Solana layer 1, which has a fair bit of room to run. At that point, you have enough credible neutrality, you have enough ecosystem usage and global growth and recognition that everyone says, okay, this is the future. And then how do we extend this thing further? And you extend it further with zero-knowledge rollups. That's what I think is the highest probability outcome.
What just overall has you most excited? And the fun way of asking this question is the Nassim Taleb line, like, don't tell me what you think, just tell me what's in your portfolio. On a relative basis, how excited are you about Solana relative to other available investments? And just kind of overall, you've been in this ecosystem, I think we first talked 6 years ago or 5 years ago or something. You've been around a long time. How does the opportunity set and landscape feel today? What has you most jazzed up?
Solana is publicly our largest position. We own a lot of it. We've sold almost none of it from 4 cents to $140, $150. And we don't intend to sell anytime soon. We're holding. So yes, what's my portfolio?
So a lot of Solana.
A lot of Solana is the answer to the question. Let me zoom out from there. So I think there's like 3-ish major categories of things happening on top of blockchains today. One is DeFi, and then things on top of DeFi, but I'm just going to call that DeFi for simplicity. We've talked about that a fair bit already. 2 is NFTs, but I'm actually going to not call them NFTs. I'm going to call that really creator monetization. And that's happening in music and art and text and whatever, a whole bunch of areas that's happening, TikTokers and stuff. And then 3 is really not talked about at all because it's still almost non-existent. You can just barely start to see it existing now, is reimagining various ecosystems and business models using crypto native assumptions and crypto native forms of capital formation and coordination. And area number 3 is the area I'm most excited about. Area number 3, the best example of that is probably Helium today, where Helium is a new business model for deploying and managing wireless networks. Instead of Verizon and AT&T owning all of the towers or renting them from American Tower, but I mean, same thing, owned by centralized entities. What if anyone can set up a tower or a hotspot in their backyard or in their window and create localized coverage for their area and then charge people per byte of data as they walk around? And that's like one of those ideas, if you really think about it, it just like obviously makes sense. There's a lot of hard technical problems to solve to make it work. It's just the world should support that model of wireless networks. So that's what Helium is. Helium was a little bit too early, just like held to deal with a whole bunch of dumb technical problems. They tried to launch on Ethereum, couldn't do it on Ethereum, built their own blockchain. Unfortunately, they launched before Solana was a thing, and they're now like annoyed that they don't have Solana. It works now and is starting to scale up. We recently led investments in 2 other things that we have not yet announced that look kind of like Helium, where it's the idea of, hey, you need people all over the world who don't trust each other to do something in some sort of coordinated fashion. Can you give them a bunch of tokens, hand them out, and then create some sort of business flywheel around getting people to do stuff? And where the do stuff, the first version of this, by the way, was Bitcoin. The thing is the do stuff was not productive. It was run hashes and mine some coins. It's kind of useless for the world. Helium is the first version where the thing people are doing is value creative. And I think you can do that. I think there's going to be hundreds of new companies and protocols built around this kind of model. And I think once a couple more of these things get some public recognition, reorienting problem spaces in this way, I think that's just going to cause an avalanche of entrepreneurs to like all go and say, okay, I want to like rebuild this sector of this industry and this new model.
And the last thing we do in these conversations each time is ask for one lesson in 2 categories. The first is a lesson for other builders or entrepreneurs, and the second is a lesson for investors. So as you think about your experience with Solana, anything going from 4 cents to $140 or whatever it is today is a hell of a journey. What lesson stands out first for builders out there? And it doesn't just need to be in crypto, it could be a general answer. From your journey with Solana, what lesson for builders would you offer?
I think it's very important if you were trying to challenge the status quo. In this case, it's like Ethereum, it's kind of the status quo. You actually want to lean into your differences. And so that should be in terms of the messaging. So for example, like starting late 18 through kind of 20, refrain was like, talking about TPS is stupid. It's like bad. And like, why would you want to talk about system performance? It's a blockchain. And that like became the prevailing narrative among crypto people. And then people also said, well, look, if you are going to launch a new thing, you have to support the EVM. You have to be backwards compatible with all of the Ethereum-based coding and applications because the Ethereum ecosystem is so large now and so dominant, you'd be stupid not to. Solana like broke all of those rules. I'm absolutely convinced that was, with a little bit of hindsight now, I think that was the right move. Because by leaning strongly against the status quo, what you end up doing is you become a shelling point for other people out there in the world who may agree with you and don't agree with the masses to then aggregate around the new thing. And you can get the snowball rolling in that new way.
Is there a different lesson that you take as an investor, especially given that whether or not your stake's been liquid or not along this way, but it seems like it's one of those examples of if you're going to make your returns as an investor from crazy outlier outcomes, almost the most important thing beyond being in the outlier is being able to hold it and not sell $4. You would have been at 100x or something. And so how do you think about investor lessons from the experience with Solana?
Our tokens unlocked January of this year when Solana was called $1.50 or thereabouts. We kind of just continually bought tokens from May of 18 through earlier this year at various prices. I definitely appreciate common thing VC say, which is liquidity is a bug, not a feature. You can't imagine how many excruciating debates we've had internally about selling SOL over the last year. It creates a lot of very, very painful conversations of like, sell, we're not setting profits. And there's just no way around that, unfortunately. We've been fortunate to have stuck it out. But yeah, it's just a matter of conviction. And the way we've framed it internally is, can Solana be the most important piece of financial infrastructure in the world in 10 years? And I think today, the probability of that is actually pretty high. I don't think that necessarily, by the way, precludes Ethereum's existence or relevance. Actually, my base case is that they coexist. But I think it can be the most important piece of financial infrastructure in the world. And if you agree with that, or you assign some reasonable probability to that, call it even 10 or 20%, you don't have to assign a 50 or 60% probability to that. But if you do, then is it still worth holding at the current price? Is that still EV positive? And like, it's obviously wildly EV positive. We continue to take that framing and believe in EV and yeah, hold on.
I'm realizing at the end that we spent all this time talking about Solana and really didn't talk about the team or the structure of the thing itself. Is there anything there in closing as the last question that you think is critical for listeners to understand about who is behind this project and who will drive it forward?
Yeah. So again, this is one of those things where lean into your differences and don't necessarily do what is common refrain is important. The Ethereum Foundation has been very hands-off as it pertains to ecosystem development. I would argue to like in a very value destructive way relative to what Ethereum could otherwise have been, where they've basically built no infrastructure around Ethereum. They have basically underpay or don't pay core developers at all. Their view is community. And there was some value to that. I don't want to harp against everything they've said is wrong, but they've really taken that to an extreme and have maintained that position since launching Ethereum in 2015. Solana has said, look, guys, okay, we built our blockchain, we launched it. We obviously have some bugs and performance things we want to fix over time, and we'll continue to iterate on those like any other team. Ethereum is doing ETH2 and all this other stuff. But like, let's also look at what are the base primitives that we need in our ecosystem? And let's like make those really good. And then let people build on top of those. Serum was kind of the first one, which was really a collaboration with the FTX team. The next one that they launched was called Metaplex, which was launched in May of this year. Metaplex was a platform for building NFT related applications. And it supports throw things on Arweave for storage. It supports transaction resale fees. It supports a bunch of like other features you would want in kind of an NFT layer on your blockchain. Solana team built it and gave it away and forked 2,000 times in the last 30 days. And then I can say they have a couple of other pillars they're working on with similar ideas where they said, look, we know that this problem space is applicable to Solana. We're going to build some of the base primitives around it. We're not going to monetize it at all. We're just going to give it away and then make it easier for developers to go do stuff. And so if you look at what Solana Labs is doing today, that's like what Solana Labs has been doing and continues to do. And I think it's a real strategic difference from Ethereum. And I think it's been necessary if you're the underdog, right? Like you got to catch up, you got to try different things differently. And I think that strategy has been very effective. I think they'll continue to lean into it. What does that mean in terms of organization? I think Solana Labs is like 70 or 80 employees today. It's not huge, but it's at least a decent sized organization now. I'm guessing a year from now, it'll be like 200 people. I don't think it'll ever be 1,000 people, but probably a couple hundred people is the right size.
Well, this has been just completely fascinating. I mean, we talk about anything that has the potential to be, like you said, even if the probability is low, a huge piece of financial infrastructure in the future. Not many things can make that claim. And I think all the ideas you've had about what it enables is what makes this so interesting, along with the technical details. Kyle, thanks so much for doing this with me and breaking down Solana.
Hey, Patrick, it was a pleasure. Happy to be back on the show.
To find more episodes of breakdowns ranging from Costco to Visa to Moderna, or to sign up for our weekly summary, check out joincolossus.com. That's JoinColossus.com.